In 2016, deep within the heart of a Canadian mine, a team of geologists uncovered something that would change the way we think about life on Earth. They discovered water that had been trapped in rock for over 2.6 billion years. This ancient water, locked away in a subterranean pocket nearly 3 kilometers below the surface, was not just a rare geological oddity. It was actively bubbling up from beneath the Earth. This discovery opened a window into Earth's deep past, offering insights into how life might survive in the most extreme environments, both on our planet and beyond. The water, initially thought to be a mere trickle, was flowing in substantial quantities, and its chemistry hinted at something truly remarkable. Unlike water found in more modern surface environments, this water contained sulfate produced by a unique chemical reaction with the surrounding minerals. The water had been isolated from sunlight and atmospheric conditions for billions of years, and yet it remained chemically stable, providing scientists with a time capsule that preserved vital information about Earth's distant history. Professor Barbara Sherwood Lawler, the lead scientist on the project, was the first to encounter this strange and ancient water. She recalls being completely unprepared for the scale of the discovery. "When we first found the water, we thought it would be a tiny pocket, maybe just a drop or two. Instead, it was bubbling up at rates we hadn't anticipated, flowing in liters per minute. It was far more abundant than we imagined," she explains. The scale of this discovery was not just surprising, it was revolutionary. For years, scientists had assumed that such ancient water would be a rare, stagnant resource, isolated in small pockets. But here, in a mine deep beneath the surface, they found an entire ecosystem, still alive after billions of years. What makes this water truly extraordinary is not just its age, but its chemical composition. When researchers first analyzed it, they found traces of sulfate, a chemical signature indicative of microbial life. But what was most astonishing was the source of these sulfates. They weren't the result of modern rain or surface runoff. Instead, the sulfates had been produced by chemical reactions occurring between the water and the surrounding rock. This process, which had been ongoing for billions of years, was entirely natural and self-sustaining. The reaction between the water and minerals in the rock created sulfate, which then provided the necessary nutrients for microbial life to survive. This finding has profound implications for our understanding of life on Earth. For the first time, scientists were able to observe life thriving in an environment completely isolated from sunlight. In this deep, dark part of the Earth, life didn't rely on photosynthesis or sunlight for energy. Instead, the microbes were using chemical reactions, powered by the radiation from the surrounding rock, to produce their energy. This process, known as chemosynthesis, is remarkably different from what we see on the surface, where life depends on the energy provided by the sun. As the team examined the water further, they found that it wasn't just traces of life, it was a thriving ecosystem. These microbes had adapted to life in one of the most extreme environments on Earth, living without light or oxygen and surviving entirely on the chemical energy provided by their environment. The microbes we found left behind a chemical fingerprint in the water, a signature that only life could create, said Sherwood Lawler. These ancient microbes weren't just surviving, they had been thriving for billions of years, creating a sustainable system that didn't require external energy inputs like sunlight. This discovery opened the door to an entirely new way of thinking about life. While most life on Earth depends on the sun for energy, these microbes have adapted to thrive in complete darkness, relying solely on the energy that can be harnessed from the minerals around them. The fact that these organisms have existed for billions of years suggests that life is far more resilient than we thought, and may be capable of surviving in conditions we once considered inhospitable. But perhaps the most intriguing question of all was not about the scientific implications, but rather a simpler, more human curiosity. What does 2.6 billion-year-old water taste like? After all, this water had been trapped in the rock for longer than modern humans, dinosaurs, or even early mammals had walked the Earth. Could it taste the way it looks? Strange, ancient, and otherworldly? Sherwood Lawler, being a seasoned geologist accustomed to tasting the minerals and rocks she encounters in the field, couldn't resist. She dipped her finger into the water and tasted it. The result? Surprisingly, it was incredibly salty, far saltier than seawater. In fact, the high salinity was exactly what she had expected, as the water had been in contact with minerals for billions of years. This saltiness wasn't just a quirk of the water's taste, it was confirmation that the water had been chemically altered over eons, preserving a snapshot of Earth's distant past. While the taste of ancient water might seem like a humorous side note, it actually provided critical evidence that the water was what the researchers had expected. It had been in contact with rock and minerals for so long that it had absorbed a unique chemical signature. This wasn't just water from a recent geological process. It was water that had undergone chemical transformations over the course of billions of years, offering a rare glimpse into Earth's early history. The discovery of Earth's oldest water isn't just a scientific curiosity. It has major implications for our understanding of life beyond Earth. If life could thrive in such extreme, isolated environments here on our own planet, without sunlight, without oxygen, then perhaps life could exist elsewhere in the universe in similarly extreme conditions. This discovery points to the possibility that life might not just be limited to the surface of planets like Earth, but could exist in the deep, dark, and cold environments found on moons like Europa or planets like Mars, where sunlight never reaches. Europa, one of Jupiter's moons, is a particularly interesting candidate. Beneath its thick, icy crust lies a subsurface ocean, and scientists have long speculated that conditions there could support microbial life. If life can exist deep below the surface of Earth, where sunlight is absent, could similar conditions exist on Europa? The water found in Canada provides a model for what life might look like in such environments. In fact, the discovery has reignited the search for life on other celestial bodies, offering hope that microbial life could exist in places we once thought inhospitable. Similarly, Mars, with its cold and barren surface, may have pockets of water hidden beneath its crust. Scientists have already found evidence of ancient lakes and riverbeds on Mars, and some believe that liquid water still exists underground. The ancient water discovered in Canada could provide vital clues about how life might survive in these extreme conditions. If life can survive for billions of years without sunlight here on Earth, it could also survive on Mars, in the deep, dark places where liquid water still exists. In the end, the discovery of Earth's oldest water offers more than just a fascinating scientific finding. It invites us to rethink what we know about life itself. Life is more resilient, more adaptable, and more pervasive than we ever imagined. This ancient water has given us a glimpse into Earth's distant past, and it has opened up new possibilities for the future, both on our own planet and in the farthest reaches of the cosmos. What we once considered impossible is now a real possibility. Life, not just on the surface, but in the hidden, forgotten places beneath our feet, and perhaps in the far reaches of space as well.